So we are to absolute value inequalities, and for this particular section it's going to be long. I wanted you to get lots of practice yesterday with solving absolute value equalities, so when we got to inequalities it would just be changing one or two things. But I need to give you lots of examples, and I need you to practice a lot so that you'll understand it, because this is the last time you're going to get it. This is it, last section before a big old test, and this is going to be on the test. So, yesterday we did equalities, and we didn't have to worry about this. We just had our two cases. We had a positive case, we had a negative case. Well, we still have two cases. We still have a positive case, we still have a negative case. That hasn't changed. What has changed is what happens with those two cases. So our positive case, we said you write down exactly what you see, nothing changes. You just take off the absolute value signs. So that's still the case. Nothing changes, even my sign stays the same. Everything stays the same. But for the negative case, that's not quite the same. We do take off the absolute value sign. We do change this to a -6, but you also, when you flip this to a negative, or whatever the opposite sign is, you have to flip that too. So you flip both. For the negative case. That's the big difference with the inequalities so far. That's the difference in the cases. So over here, when I go to solve this inequality, you know you add 4 to both sides. And we get y is greater than 10. That's good. Over here, when we go to solve this one, we add 4 to both sides. And we get y is less than -2. And that's fine. And normally, if we had an equal sign, we'd just throw a big old or in there and be done with it. That's not the case anymore, because that's not an equal sign, which means it's not an understood or anymore. Now we have to look at whatever sign it is, and you want to look at the sign when you take the absolute value bars off. That's important, because your sign can flip around and change before you ever get to that point. So when you take the absolute value bars off, you look at it and you figure out if it's an or if it's an and. This one says that it is greater. Which means it is an or problem. So if it's or up there, it's or down here. If it was going this way, it would be a less than problem. Great or and less than. That's how you remember them. So down here, we're not done yet, because we did solve it. That's great. We got the solving part done now. Now we have to graph it. Remember, when it's an or problem and we're graphing, everything gets put on our graph. So I got my -2, my 0, over here somewhere is a 10. Open circle at 10, going that way. Open circle at -2, going that way. So now I've got it graphed, I got it solved, I got it graphed, and now I have to write set builder notation. Y such that y is greater than 10, or, just like it is there, y is less than -2. For the next one, a minus 2 is less than 5. So that means when I go to split it up, because it's already isolated, I have a minus 2 is less than 5. That's my positive case. And then a minus 2 is greater than a negative 5. That's my negative case. Remember, you gotta flip both signs. Add 2 to both sides. A is less than 7. Add 2 to both sides. A is greater than negative 3. Up here, my original problem was less than, so that makes this an and problem, which means this is going to be an and problem. When we have and, it's the stuff they have in common. So down here is my negative 3, and over here is my 7. Over here somewhere is a 0. Open circle on 7, open circle on negative 3. Negative 3 is pointing that way. 7's pointing this way, which means it's the stuff in between that ends up getting shaded. Now, I didn't write down what each of them did, but I did say this one points that way and that one points that way. So I did it in my head, even though I didn't write it down. All I wrote down was the answer. It's okay with me if you do both, but I need you to understand that's what I did. I did actually do them both in my head. And then for my set builder, A, because that's what my letter was, such that A is less than 7 and A is greater than negative 3. Now I know you're thinking, alright, those are the examples, let's get on with classwork, do the homework, be done. No. More examples to come. Lots more examples to come. Great or less than. Try those three real quick. Let's see how you do. So this one's going to be x minus 3 is greater than 7, or x minus 3 is less than negative 7. X is greater than 10, or X is less than negative 4. Open circles. Negative 4 pointed this way. It's an or, so it all gets put on one anyway. And the 10 pointed this way. Ta-ta. For the next one, 2t minus 3 is less than 0, and 2t minus 3 is greater than negative 0. Hey, wait a minute. How do we have a negative 0? 0 is just 0, right? I think it's the same thing. So it's either going to be less than and greater than. Okay. Working it out. 2t is less than 3 divided by 2. T is less than 3 over 2. 2 plus 3 plus 3. 2t is greater than 3 divided by 2. T is greater than 3 over 2. And over here is a 0. Here somewhere is my 3 over 2. This one is an open circle going that way. This one is an open circle going that way. When do they cross? They don't cross. So the answer to this one is no solution. If there is no solution, that's the solution set as well. That's the graph as well, because there's nothing to graph. So there's no solution. So you gotta use your thinking cap for this stuff. For this one, 2x minus 1 is less than or equal to 5. 2x, minus 1, because that stuff doesn't change. It's greater than or equal to negative 5. Just flip the sign over. So 2x is less than or equal to 6 divided by 2. X is less than or equal to 3. And, because it's less than, 2x is greater than or equal to negative 4 divided by 2. X is greater than or equal to negative 2. Negative 2, 3, and a 0 in here somewhere. Negative 2 is solid, goes that way. 3 is solid, goes that way. So it must be the stuff in between them. When I go to write this one, I can write it the way that we were doing our combined before. I don't have to write this and that. I can. It's okay to write that. But I can just put the negative 2, make sure I do my less than or equal to 3. Just like we were in the other one where you shaded the stuff in between. Now ors, you can't do that on, because ors we have both. But for an and, you can do that. You can either write it the way it is up there, or you can rewrite it like that. Now you're thinking, surely we've gone over everything that could be in this section, right? But wait, there is more. More hard stuff. More challenges. More excitement and ingenuity. Okay, I got carried away. Give you a second to look at these, if you can see them. Yeah, there was really no need to pause. Your second should be up by now anyway. For this one, we add 4 to both sides, right? Let me ask you a question. Can we ever have an absolute value that's greater than -2? Well, sure. Can we have an absolute value that's less than a -2? No. The reason we can't is because the absolute value is always going to end up being positive. So yeah, it can be greater than -2, but it's never going to be less than -2. So you want to kind of keep an eye on what your answers say. So here we're going to have x minus 4 is greater than -2. X minus 4 is less than +2. And it's an OR. Is open circle going this way. 6 is open circle going this way. Is there anything that didn't get shaded? No. So when I go to write my solution set, I can just write all real numbers because it included everything. There's no need for this. Yes, we solved it. We solved it good. But when you go to look at what you actually graph, it's easier just to write all real numbers than it is to write that, because that's what it would be. And this is more accurate than writing that, because it tells me you actually looked at it and saw what you did. You weren't just going right along. Up here, we have two different problems. We have 2 minus 3x over 2 is less than or equal to 1. And then 2 minus 3x over 2 is greater than or equal to -1. No, that's a big shocker. But we do have to multiply by a 2 to get the 2 out from underneath there. Then I can subtract 2. -3x, and oh sorry, I was subtracting 2. That's 0. Can I have a 0 there? Divide by -3, flip the sign. X is greater than or equal to 0. Don't forget to flip, that's important. This is an and or. Less than, so that makes it an and. Multiply by 2, so 2 minus 3x greater than or equal to -2 minus 2 divide by -3. Flip the sign because you're dividing by a negative. 4 over 3. And we said it was an and. Okay, so let's look at it. We have 0 here, 4/3 here. Solid going that way. Solid going that way, which means we're going to shade the stuff in between. And you think, okay, surely we're done now. Well, I'm tired. And I have 2 problems left. But did I mention I'm tired? And I don't think they are any more difficult than what we have looked at. So we're going to skip those 2. We're going to call this done. You should not be tired. You haven't been working for hours on this yet. I'm just saying today's a hard day. I admit it fully. Classwork. Page 212. Practice exercises. Numbers 4, 12, 24, 34, 38, 40, 48. 7 problems. Homework.
I know it's hard to get all the departments.
Practice exercises. Numbers 1, 13, 21, 29, 33, 39, 41, 45. We're not doing word problems in this section. In this chapter. We're not going over word problems. I think word problems with inequalities in it is a ridiculous prospect anyway. But I did want to give you a little bit of review for your test so you'll know what to do. So if you will look, well, look at it. Hold on. La da 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 da, la da 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 da, la da 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 da, la da 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 da. Ooh, on page 201, they have a little test yourself down at the bottom. That covers sections 5.1 through 5.4. That's really good. I'm just saying, for those 4 sections, that's a good review. Then, on page 221 in the summary and review, problems 5 through 18 are really the ones you need to concentrate on. 5 through 18. They wrote some things down there to help you remember things you need to know. But if I were you, I'd just worry about doing the problems. Make sure you pay attention as to whether or not they want you to solve it, or solve it and graph it, or solve it and graph it and write the solution set. Because I will have different ones like that on there where you have to solve some, you have to solve and graph some, you have to write a solution set for some, you have to solve, graph, write a solution set. You need to make sure you read your directions so you can carefully do them. Whenever they say check in the book though, that just means check your answers. I am going to, as part of your review, I'm going to go ahead and do the problems that I've just told you about on these pages so that they can already be worked out for you so that you can have them to look at and they'll be worked out, not just have the answers there. And that'll be the best review I think you could possibly get for this section. The next chapter is a little bit different. You're going to be taking different kinds of notes. Your mom's going to have to print something out for you. Make sure she does that before you start chapter 9, because that's the next chapter we're doing, is chapter number 9. I will talk to you later. Bye.